Here's some Hadoop resources. You remember it?
Yes, sir.
Okay. Now, first, we know HDFS is the main part of the Hadoop. So first, we learn about the Hadoop distributed file system.
Hadoop.
Yeah, Hadoop. Do you know?
No, I don't know.
Okay. Okay. We form four motivation, architecture, and concepts inside user interface. 3 parts to learn about Hadoop. Okay. The first motivation questions. Problem 1. We know we are in the age of big data. So the first problem is data is too big to store on one machine.
Yes,
Too big to just 1 PB. Okay.
yes.
So Hadoop store the data on multiple machines. Oh, this is a very cool characteristics. Okay. Hadoop can manage thousands of machines, storage machines. Okay. Okay. It's very cool. Okay. The problem 2, very high and machines are too expensive. There are many computing center. It's very expensive. We will build a computing center. Okay. A computing center, super computing center.
Yes, yes.
We have a Alibaba computer center.
Yes.
In that corner. Do you know?
I don't know.
We expense about nearly 1 million. A term 8 million.
8 million.
8 million.
8 million yuan or US dollar?
RMB.
RMB. Wow, it's a big amount.
Yeah, it's just a small.
Small. Okay. How many?
Yeah.
Processors? How many computing units?
Computer maybe course.
How many cores?
1,000 about.
1,000.
Yeah.
It's like super processor.
This is the first. The data is very big. We cannot handle it in one machine.
This kind of machine is impossible.
Yeah.
Maybe it will take 1,000 years.
Is it 1,000 years?
Yeah, by this computer.
Yes. But if we have a Hadoop, Hadoop can management
All the
and use thousands of machines. So Hadoop can use thousands of machines to do a computation. Meanwhile, yeah, manipulation. The problem 2, very high end machines are too expensive. Okay. But for HDFS, run on commodity hardware. Cheap. Okay. Cheap. 100% cheap for building parallel computing.
But maybe they need different kind of motherboard chip to put 1,000 at the same time together.
Yeah.
It's different than our consumer level processor.
Yeah, it is different from the one super computing center. HDF can use the older machines and combine them together to do one thing, just like a general. Okay. The problem 3, commodity hardware will fail. Failure is normal. Failure.
Like some processor will not work.
Yeah.
Hardware
Yeah.
suddenly will not work.
It's a normal status.
Then how to recover it?
How do we
How to recover?
Docker.
recover?
Yeah.
Hadoop use the backup. Backup. Every data in Hadoop have 3 copies. 3 copies. Okay.
Docker is
When one copy is done, another will continue it. So in Hadoop, software is intelligent enough to handle hardware failure. Very smart to process the hardware failure. Okay. Depend on the such mechanic.
Maybe this happens often in the data centers. Like they have millions or billions of hard drives. Like one hard drive can be broken sometimes.
Yeah. And another will continue.
So how does it work?
In Hadoop, there is a very smart mechanism to do that. Okay. We can discuss it later. Okay. Just now, we discussed about the programmer have 4 things don't care. One of the thing is failure. For program, we just program. We don't care about the failure. If a hard drive is failure, you don't know.
Yes, sir.
The HDF will automatically recover or replace it. Use another machine or drive with a backup. Okay.
Yes, sir.
Normally, we just have one data in a drive. In Hadoop, have 3. 3 mirror.
Like same copy of the same.
Yes.
Copy.
3 machine have the same data, same configurations. When one is done, another will start automatically and continue the task.
That's right.
Is smart?
Yeah.
So HDF is very smart.
Yes.
So software is intelligent enough to handle hardware failure. Okay. 3 couples. So redundant is good or not?
It's good.
Sometimes it's not good. For traditional database, redundant is not good. For table, many duplications, you will feel crazy.
Like waste of power sometimes.
Waste of power, waste of space, waste of resource.
Yes, sir.
Okay. But for Hadoop system, for the data available, sometimes redundancy is good. Okay. If you are writing a dissertation, you should have made many copies. Okay.
Yes,
that is necessary. If you complete your dissertation 90%,
and only one copy.
only one copy. If the hardware is failure, what should you do? Cry?
I'll cry.
It's crazy. Okay. So redundant, multiple copies in some scenario is very it's necessary. Okay.
Yes, sir. We had to cry so many times.
For your homework, is the same. Make a backup.
GitHub.
Yeah. The best online on cloud.
Cloud is the best, right?
Yeah, into the cloud. There are many free cloud space. Okay.
So what is the best Chinese free cloud space?
Just if you have a Chinese phone, every provider will give you a
5 gigabyte or 10 gigabyte.
5G gigabyte.
5G is
Yeah.
too little.
Yeah.
So lower cloud is
You can use the Tencent, Huawei.
Or Bible net this.
Yeah, and
near cloud.
yeah. Many. You can choose one. Okay. Do you use cloud? Last class, we introduced the cloud phone. Do you know what is cloud phone?
I was not there in the last class.
All the applications installed in the server, your phone just end facility.
Now phone need super fast internet, like 5G.
Yeah, 5G. Yeah,
5G.
very smart guys. For cloud phones, we need a 5G support. Okay.
Right now, so many providers making 5G phones. Right now, we are having 5G phones right now. It's available.
Is available.
Yeah.
In China,
very fast, like
if you
1400 mega.
1400. Okay, 1400. 1400. Okay.
It's super fast.
Super fast. Yes. If you change your phone now, you buy any phone is 5G.
Yeah, new phone, any new.
And new phone, all is 5G.
Any phone.
Expensive.
Yeah.
Samsung, OnePlus,
5G মোটামুটি 2000 বেশি দাম 5G
এই সব মোবাইল আইফোনই তো বাইরে করতে পারে
আইফোন পাওয়ার সাথে
ওয়্যার কত সব মোবাইল তো
আইফোন নতুন এখন যে ফোনটা বাইরে আইফোন 12 যেটা
Okay. Minaj is very smart, guys. Okay. Learn more about Chinese things.
Yes, he knows so many things.
Yeah.
Yes, sir. Thank you, sir.
If you use more time
To study.
that's
I'll do it, sir.
that's awesome.
Come to your class.
Come to class. Oh,
Yes, all the
this is a good start.
Yeah, this is a good start after 2.5
Yeah.
and I let I'm not
Commodity hardware. Okay, this is problem 3. Another problem 4. What happens to data if the machine stores the data fields? What happens to data? What happens if the machine store the data fields? We just discussed it.
Yeah,
If just one copy, is a disaster. Nothing. Okay. But for HDFS, we use replicate the data. Replicate. You know, normally 3 copies. Okay. So when we look at things, we should in different angles, different views.
Yes, sir.
Redundant for resource wasted. Okay, but he can keep safety. Okay, redundant means so resource waste. The first side. Another side is keep safety. Okay. In the world, there are no people, a theme. So people no replicate. If you use the clone technology. Okay. The problem 5. How can distributed machines organize the data in a coordinated way? How can distributed machines organize the data? You mean not just now?
Yeah.
Present these questions.
Yes, sir.
Now the answer is here. Organize the data in a coordinated way. Master-slave architecture. There is a master, the slave.
How does it work? Master-slave architecture.
Master always one.
Like one command.
With your name node. Other is data node. Okay. Just like
Can you give us
just the
an
leader
example?
and the ordinary,
Master slave architecture.
yeah.
Example.
Mm.
Example. Can you show us some example?
হাঁটু পর্যন্ত যাইতে দে
就像 just like the leaders and their ordinary workers. Okay.
আমাদের মূল জায়গায় যাইতে দে আর যাচ্ছেন তো
The master slave architecture.
Yes.
শুরুই করতে হবে
This is HDF architecture, master slave. Please look at here. The first is name node. Okay. Other is data node. A second name node. Okay.
Yes, sir.
Name node is a master. Controller. Okay. Just like a leader. First system namespace management. Block mappings. Name node do two things. Control two things. The first, management of the file system names. Which file in there? The parts. Okay. How big? Okay. Another thing is block mappings. Divided up task into many small ones.
Yes, sir.
Okay. Just map. Block mappings. Another, the second is sleeve. Sleeve is data node, workhorse. Each workhorse. Data node for data computing. Okay, and store. The first, so there I have two missions. The first is block operations. The name node make many small blocks. And so every block stored into a data node.
Yes, sir.
Okay. And the replication it. Okay. For safety.
Yes, sir.
Now the second name node, checkpoint node. Checkpoint node. Okay, this look at this structure. This is the master, the red one. Okay, dark red one. Name node NN. Did node DN sleeves. Secret cluster. Just like a leader and an ordinary worker. A multi-rank cluster, a switch, do you know switch? Okay. A facility of network. Name node, secondary name node, the bottom is the data node, DN, okay?
Yes, sir.
If a task came first, they enter the name node and divide into many blocks, and then storing the data node and the category management by name node. Okay. Here, name node. I know all blocks and the replicas. Okay. Blocks splitted by name node, and the name node management all the blocks. Okay. So the name node know all blocks and replicas. Keep a reliable storage. And will replicate lost blocks in another node. Replicate lost blocks in another node. This mechanism can keep safety. If this is lost, maybe this two is the same as this one. So the name node find another good data from the backup. Three for group. Okay, a group have three copies. If one copy is lost, we find from other tools. Okay, can you understand?
Roger. I didn't understand. That's not.
Just now?
Yeah.
Oh, okay. That's good.
Is correct.
There is a demonstration. Here. Do not ask me. I'm done. If a name node is done, who will
Secondary.
start up? Secondary name node. Okay, these two synchronized same time. Okay. If name node is done, a secondary name node will used. Okay, used. This is another architecture, a multi-rack cluster. How about the network performance? Yeah. Okay, this is inside of name node. Just now is overview. Okay. Now we inside the name node. Yeah, name node. Here is the file name, replication factor. Okay. I have block ID. One file have 3 copies, and every copy have ID stored in the name node. Any question about this graph? Okay. Just like a file one was divided into 3 parts. Okay, 3 replications. ID is 1, 2, and 3. And the data not stored in the name node. They stored in the data node. Okay. 1 stored in here. 2 stored in this node. This node. Yeah, 3 copies. 1, 2, 3. Okay. Every data block have 3 copies. To ensure what? Safety. To ensure when some blocks lost, we can find it and recover.
Yes, sir.
Okay. This replication is good.
Yeah, very good.
A name node, first system image, edit log, periodically, second name node, FS. This 2 is the same. 1 is for backup. Okay. Every data nodes have a heartbeat. Heartbeat? Do you know? Heartbeat. That means periodically check the status of the name node. If the name node, just like me, are you okay? Are you okay? Are you okay? If I ask everyone, time wasted, resource wasted.
Yes, sir.
I just call you. Are you okay?
Yes, sir.
Are you okay? It's very resource and time waste.
Yes, sir.
So another new mechanism, heartbeat. Everyone periodically send the message to me. I'm okay. I'm okay. Okay. This is heartbeat. Okay. Everyone give me a message. I'm okay. Needn't I ask you which solution is good?
We tell you that we are.
Yeah.
This method is good.
Yeah. If okay, you needn't give me a message.
Yes.
Yeah. I'm bad. Oh, I'm fever. Okay. So every data node periodically have a heartbeat. Okay, let the data note know I'm good or not, I'm down or not. Okay. Wait a minute.
ছুটি ছুটি সব কুমা খালি তার মনে করছে 11 রে ভাই এটা রস্তে কখন বলবো আমরা তো জানি কেন কেন লাগলো এখন বলছি Name is W. Then is keep up. You will have it. C or C++ compiler. Session.
Okay. Heartbeat. We design heartbeat for what? For what? For communication between the name node and the data node. Data node tell the name node his status. Here's the status. I'm working, I'm done, okay? Something like that. Okay. Another keywords blocks. Okay. Why? We need cut a file as many blocks. Why do we need the abstraction blocks in addition to files? A reason here have 3. File can be larger than a single disk. These are reality, real questions. Some file is very big. Is very larger than a single disk. Okay. Maybe one file is 1 TB. Yeah, terabyte.
Okay. If there is 1 terabyte file and we have 500 gigabytes of hard drive.
Yeah, maybe there have one file with 2 gigabyte. Okay. So this is the situation. Another block is fixed size, easy to management and manipulate. Okay. Easy manipulated and management. The third, easy to replicate and do more fine-grained load balance. For load balance is very important.
Yeah.
Just like the integrating box. Okay. Do you know that?
No. I don't know. Maybe Arif knows. Arif is a proper. Yeah, he's the best one.
Because every blocks need 3 copies.
Yes, sir.
So if we cut it at the same size, block have the same size.
Yes, sir.
So it is easily for management and replicate. Okay. Container.
We will finish
All the,
last Syrian Banjar. Syrian Banjar.
you're hungry?
Yes.
Syrian Banjar.
Well, how many slices? Let me check. We cannot introduce one. Okay. If you are hungry.
Syrian Banjar.
Okay. This is the reasons why we use blocks in HDFS. The first is file can be larger than a single disk. Block is a fixed size, just like a container. Okay, container is fixed size. Okay, for fixed size things, we can place it more efficiently. Okay, and easily. So easy to manage and manipulate. The third is easy to replicate and do more fine-grained load balances. Some container have small, some let the balance. Okay, make balance. HDF block size, how big is by default 64 megabit.
64
Megabit, okay, 64 megabit for one block. If you have a file, if his size is 256, okay, how many blocks will be cut? 4.
Yeah.
Okay.
Yeah.
4 blocks. If you have a whole file, his size is 256. According to if you store it into HDFS, this file will be divided into 4 blocks. Okay, and the 4 blocks stored in different name node, and every blocks have 3 copies, replications.
Very safe.
Very safe, yes. Very safe and have a fixed size, easy to management and manipulate. Okay.
Yes,
That's why it is much larger than regular file system blocks. 为什么它会？Why? Why a block is much larger than regular file system blocks? Normal file system blocks is smaller than HDFS blocks.
Okay. How is the regular one?
Regular just like a GFS.
Yeah.
Okay. So
How big it is?
maybe is
because they use a
several KBs. Yeah.
maybe they use head and they use the block.
Different file system have different size, but no one larger than 64. Yeah. Here is reasons. Minimize overhead. Disk seek time is almost constant. Minimum overhead. Okay, the first. Second example, seek time term minutes. Okay, millisecond. File transfer rate 100 megabytes per second. Overhead seek time or block transfer time is 1%. What is the block size? You can calculate. Okay. So this is why we use the 64 megabyte. Okay.
Yes, sir.
read. How to read data in HDFS. This is a step 1, 2, 3, 4. Okay. First step. What is the first step? Client send a request to name node. I want to read some files. Okay. A name node return the files information, and the client, according to the information, to fetch data from data node. Okay, data node. Here is the three steps. Client connects to NN to read the data. NN tells client where to find the data blocks.
Yes, sir.
Client read blocks directly from data nodes without going through NN. Client just directly read the data. In case of node failure, if some node is failure, client connects to another node that serves the missing block, the backup. Okay, the copies, replicate. Okay, is here.
No, Lashi, more 5 minutes.
5 minutes? Okay. Okay. If you do not hungry, we continue. 5 minutes? 5 minutes. Okay. 5 minutes. Okay. Okay.
Yes, sir. We continue.
Okay. 5 minutes. Okay. Do you learn about the read data process?
Yes, sir. Yes, sir.
No. First, client. What is client?
Client means
Who wants to read the data?
Yes, sir.
Okay. If the client wants to read the data, first, the client connects to the name node. Okay. Why client should connect to the name node? To get information about the file.
yes.
How many blocks the file have? Okay. Where is every block in which data node? Okay. Okay. So connects to NN to read data. NN tells client where to find the data blocks. You have 3 blocks. The first in which computers and the data node. The second in which data node. The third in which data node. Okay. If client knows this information, then the client disconnected with the name node. Then client reads blocks directly from data nodes without going through NN. Okay. The third, in case of node failure, if this node is failure, client connects to another node, the backup ones, that serve the missing block. Why does HDFS choose such a design for read? Why not ask client to read blocks through NN? This is a question. Okay.
Question.
Why does HDFS choose such a design for read? Why not ask client to read blocks through NN? Why client read the blocks directly from data node? Here is the 3 reasons. The first, prevent NN from being the bottleneck of the cluster. Everyone wants to read the data to access the NN. There be a bottleneck. Okay, the bottleneck. communication jam. The second, allow HFS to scale to large number of concurrency clients. Concurrency, do you know? Concurrency?
Yes, confirm.
Many clients access a thing in the same time. When you want to choose a course, thousands of students access the server in one time. Okay, at the same time. Yes. The third, spread the data traffic across a cluster. Is one kind of load balance. Okay, for load balance, spread the data traffic across the cluster. Is a balance, loading balance.
Like same speed all over the cluster.
Yeah. Given multiple replicas of the same block, how does n decide which replica the client should read? There are many copies. Which one you should read? Solution. Rank awareness based on network topology. Okay, based on the network topology. 3 is the same. Which one is okay? Everyone is okay.
Yeah, everyone is okay.
Yeah.
Which one to select? Which one to choose?
Based on the network topology. Okay. Awareness. Okay. Read is complete. Next time we will
Practical.
Network topology and the right and the interface, web UI, command line, summary. Next time. Okay.
Yeah, so
This is here.
yes, sir.
So we want to do like practical work.
Practical,
learn,
yeah.
like, learn
Predict?
the theory.